So we are still working through chapter 1. There is a worksheet today, just like yesterday. Like I said, we're still trying to figure out which sections we like the book for, which ones we kind of just want to use our own stuff. So today it'll be another worksheet. We are getting into more challenging equations. Like I said when we were going over the homework, if you didn't show a ton of work yesterday, it's not the end of the world. I don't like it, but I can deal with it. If you don't show work today, it is the end of the world, okay? I need to see work for every single step that we're doing today. All right? We will continue with the solving equations, multi-step, a lot of word problems tomorrow. Thursday, we're going to review. Friday, we have a quiz. I'm a little concerned about Friday, not for this class, but my other class is 7th hour, and since there's an assembly, it'll be cut pretty short. So I'm pretty sure I'm going to give you guys a normal size quiz, but stay tuned, okay? Still working through it. All right, anyway, here's what we're working on today. So these are equations that we cannot just solve in one step like we were doing yesterday. Yesterday we just subtract 3, we'd be done. We cannot do that today. So we need to undo a few things. Here we need to undo multiplying by 5. We need to undo adding 3. The way you decide what to do first, it's the order of operations but in reverse. So normally we would do multiplying, then we would add, right? But if we're going in reverse, we're going to do everything backwards. So we're going to start by undoing the adding and subtracting. Then we're going to undo the multiplying and dividing. So how do I undo adding 3? Subtract 3. And I'm going to do that from both sides of the equal sign. Now, some people, especially in the multi-step equations, you'll see these guys. It's like a line of equality. If you want to do that, that's fine. Sometimes I do, sometimes I don't. Personally, it's not part of a habit that I do, so I kind of forget when I'm showing you guys sometimes. But if you want to do that to help you see where the balancing line is, you know, if you do it to one side, you got to do it to the other. Go ahead and draw that line in, and then whatever you do to the left, just do to the right, or whatever you do to the right, make sure you do to the left, okay? All right, so the 5x is still on the left side. The 3's are now gone. Equals, what is 23 minus 3? 20. Now this looks like an equation that we solved yesterday. How would we solve this? Divide both sides by 5. And I'm left with x equals 4. That is my answer. Once again, you can double check these very quickly. If you plug it back in for x, you have 5 times 4, which is 20, plus 3, which does equal 23, so you can move on with confidence. Any questions? All right. Here is part B. Once again, as you're writing it, if you want to put this little guy through there, you can. All right, how do I undo subtracting 8? You add 8. So that's where I would start on this one. We always undo the adding and subtracting first. So we still have the n. We still have the divided by 3. Now it's equal to, what's negative 2 plus 8? 6. Good. All right, then what? You do what? Yes, we're going to multiply both sides by 3. So I'm going to get n equals 18. And once again, you can just pop it right in for n. 18 divided by 3 is 6, and 6 minus 8 is negative 2. Do it in my head in 10 seconds, and I am now very confident in my work. Questions? All right, here's C. Now, normally we undo adding and subtracting first. But not in this case. Can someone point out how this one's different than the last one? Yes.
It's dividing the number of 12 by 6.
So you see how the whole thing is being divided by 6. So similar to like when we talked about the numerator and the denominator sort of being like grouping symbols. You got to get through the whole thing before you can do the dividing. Now it's like the reverse, right? We got to undo the big division symbol first. I like to call these bodyguard problems, okay? I imagine the variable to be some sort of celebrity up in the penthouse suite, you know, in a hotel. Where's the penthouse? Where's the penthouse? Where do the celebrities go in a hotel?
Places.
The top, right? How do you get all the way up to the top? You go through the special elevator, okay? And in this problem, the -6 is the bodyguard to the elevator that's holding Kim Kardashian, okay? So you gotta it's just the first celebrity I heard. So we gotta get through that bodyguard, okay? S is up top, having a good old time with +12. We can't get up there, all right? We do not have access to that elevator unless we get through the bodyguard. The bodyguard is -6. How can I undo dividing by -6? So we're going to multiply by -6, and that's how we bust through the bodyguard. Now we're up top, having a good old time, okay? We're there. But we have to multiply the -14 by the -6. A negative times a negative is a positive. I'm not sure off the top of my head what that is, so I can either get my calculator out at this point, or I can do a little multiplying over to the side.
Times 7 by 12. Take it off 14.
What?
14 times -6, so technically just be 7 times 12.
Okay. That sounds good. We're not just crossing out the 6. We are multiplying both sides by -6 in order to get through the bodyguard. In order to undo dividing by -6, we multiply both sides by -6. So we're doing -6 times -14. A negative times a negative is a positive. Okay? Now we're up top. We've broken through that big division symbol. We're right where we want to be. What do I need to do? Subtract 12. 72 equals S, or S equals 72? All right? Questions? Now, is this a bodyguard problem? No, there is like a fraction bar, you know, but this is more like a fraction times a variable. So sometimes people get a little bodyguard crazy. Remember, if the whole side is being divided by a number, that's when we have a bodyguard problem. That's where we multiply both sides by the denominator. That's not the case here. Here we're just going to solve like normal. So we're going to undo the subtracting 7 first. How do you undo subtracting 7? You add 7. So again, if you want your line of equality that I occasionally forget to do, more than occasionally. All right, so I have 3/4 x equals 15. Now what? Multiply by the reciprocal. What is the reciprocal? 4/3. All right, so I have the 4's are gone, the 3's are gone, just the x. What can I do on the right side? The 15 and the 3 goes to 5 and 1. And 5 times 4 is 20, and 1 times 1 is 1, so you don't need that over 1. This would be a good one to check. If you plug it back in, the 4 and the 20 would make a 5. 3 times 5 is 15, and 15 minus 7 is 8, so I'm feeling pretty good. Questions? All right, here's E. Mm-hmm. Hold on. What? There's two people talking at once. What? It is, yes. What? Yeah, so normally if I see parentheses, just make sure everything inside the parentheses is already simplified. You can't combine the m and the 3. They're not like terms. What you can do is distribute the 6. So 6 times m is 6m. Minus 6 times 3 is 18. Plus 5m equals 4. Then what? Combine like terms. 6m plus 5m is 11m minus 18 equals 4. All right, next. Shh, getting a little chatty. Add 18 to both sides. Very good. So 11m equals 22. Divide by 11. M equals what?
2.
Very good. Once again, if I plug it in, I have 2 minus 3. That would be negative 1. Negative 1 times 6 is negative 6. Plus 5 times 2 would be 10. And negative 6 plus positive 10 is a positive 4. So it takes a minute, less than a minute, but a little longer when there's 2 places to plug the variable in, but you can still check it pretty quickly. Questions? All right, here's F. All right, what should I do? Distribute what?
5.
The 5. So I have the 5x up front. Can't touch that guy yet. 5 times 4x is what? 20x minus 5 times 1 is 5, and that equals 20. Now I have 2 spots, same side of the equal sign, like terms. Combine them. I get 25x minus 5 equals 20. Then what?
It's a negative 5.
Good. Add 5 to both sides. And then we can divide. So what do we get for our variable x? X equals 1. 1's an easy one to plug in and check because you just get 5 here. Plus, here you'd get 4 minus 1, which is 3. 3 times 5 is 15. And 5 plus 15 is 20. So we're good. Questions? All right. Whoa. Hey-o. What type of problem is this? Bodyguard. Who do I got to get through? 11. I'm going to multiply both sides by 11. Am I up top? Like, do I distribute the 11 to anything up top? It's not like 77 minus 22. That's a very common mistake. The only thing you're doing on the left is getting rid of him. All right? He never goes up to the party, okay? He's downstairs. He's the hired help, okay? And then on the right side, we do 3 times 11, we get 33. Now what?
Now we have a minus
Minus 7.
Yes, that 7 is positive, even though you see a subtraction sign or a negative sign. Don't worry about that yet. Get rid of that 7. That 7 is a positive. I am going to subtract 7 from both sides. Negative stays with the 2. What do I have on the right side? 26. And 26 divided by negative 2 is what? Negative 13. Ideas? Yes.
Start with the right side for my left hand. And then do the same for the left.
Yeah, we can combine like terms on both sides. Doesn't really matter which one you do first. You can do them at the same time. What is 7 minus 28? Negative 21 equals, what's 4x plus 3x? And now it's just a one-stepper. So negative what? 3 equals x, or x equals negative 3. Of course. Any questions? All right. Example 2. 280 students play a sport at West. This represents 1/5 of the students that attend West. How many students attend West? So, I need to set up a let statement. I am going to let what? S equals, actually we have to say the number of students. Variables represent numbers. They don't represent things. It's not like an actual student. It's the number of actual students. So make sure you have the word the number, okay? So we're going to let S equal the number of students. All right, so 1/5 of the students. So what am I going to do? 1/5 S equals 280. Good. So the way that you read this, you might have done 280 equals 1/5 S. That's fine. I just prefer the variable on the left side. I feel like it makes it easier. Either way, they're equal. It's not a big deal if you have it 280 equals 1/5 S. Now, how do I get the S by itself? Good. What's the reciprocal of 1/5? 5 over 1. Good. Which is just 5, right? Does anyone have a calculator who wants to tell us what 280 times 5? 1,400. And what are we talking about? Students. Questions? All right, example 3. -8 times a number is 56. Find the number. So I'm going to let what? Let n equal a number. All right, and then you basically just read it. -8 is a -8. Times a number,
So -8 is, or
n, x, whatever, is my equal sign, 56. Then what? And what is 56 divided by -8? -7. Good. And you don't need a label because -7 is already a number. You don't have to say like -7 number. Just, there you go. Tomorrow when we highlight, I like when you highlight one of each type. So yeah, just highlight one of the word problems. All right, example 4. If a number is decreased by -5, the result is -1. What is the number? I am going to let n equal a number. And then let's read through it again. A number is decreased by. What does that mean? Minus a -5. The result is.
-1.
What is the result is?
Equal.
That's my equal sign. And then -1. I think I knew what you meant. All right, I'm going to clean that up. This is like n plus 5 equals -1. So then what? Subtract 5 from both sides. N equals -6. Good. Questions? All right, here's example 5. One class has 3 times as many boys as girls. If there are 60 students in the class, how many boys are in the class?
20.
All right, so what are we looking for? What's my variable? What am I going to let?
Let B equals boys. A number of boys. Yeah.
Let B equal number of boys, okay? One class has 3 times as many boys as girls. All right, ideas? All right, so should we talk about the number of girls?
No, not really.
Let's just make a little note off to ourselves. So girls would be what? If I have the number of boys, I already said that I want B to be boys. So if I have the number of boys, what would I do to that to get the girls? Divide it by what? By 3, okay? So that would be girls. Is that helpful? No.
being honest.
Would it be easier if we set this up in terms of girls, you think?
I did figure out how to get the girls.
So what if we let our variable be the number of girls?
Okay, so G.
Let G equal the number of girls.
It would be the opposite if we said it's in the G. It'd be 3G.
Okay. So 3G would be what? 3G represents what? The number of boys. And we would add that to what? So if this is boys,
Wait, one.
and then this is, how do you get the total of boys and girls? You add them. So if 3 times G is the number of boys, what's the number of girls?
20. 20.
What did I just say I'm calling the number of girls? Girls is what? G. It's not in my equation though. And how many are there total? 60. Good. So we could have done this in terms of boys too. We just would have had a fraction. It might be. Okay. Shh, 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 shh. Okay. So again, one class has 3 times as many boys as girls. So there are more boys. So if I'm starting with girls, I would multiply that by 3. That would be the number of boys. But if there are still 60 students total, you still have to add the number of boys and girls together. All right? So I have 4G equals 60. So what does G equal? So there are 15 girls. That's not what I'm trying to find. I'm trying to find how many boys there are. So if I take away the number of girls, that would give me the number of boys. Or you could just remember that there are 3 times as many boys. So you could multiply it by 3. Personally, I do it both ways and see if you get the same answer. And you do, right? That's 45. Or if you do 15 times 3, that's also 45. So the reason I made you struggle through this is to show you that some of these have multiple ways you can set them up. And sometimes you start going one way and you don't like the way it works out because it kind of makes the math more challenging than if you went in a different direction. So it's okay to struggle through these. It's okay to cross out your work and start over. Sometimes it just takes a few tries to get a variable that makes sense to you. And that's fine. I still do that. I've been doing this for 20 years and I still do that. Okay? We have one more example. Are you ready? Okay. So this is a lot of what you are going to see like in a geometry class. So this says the sum of the angles of a polygon is found using the formula S equals n minus 2 times 180. Write and solve an equation to find x. I'm actually not going to do it that way. I'm going to cheat. I am going to tell you that these angles add to 360. Okay? If there are 4 sides, we call that a quadrilateral. The angles of a quadrilateral add to 360. So I am going to start with one of the angles. I'll start with the 2x plus 30. Then I'm going to add all the other angles. 2x plus 20 plus x plus 50. Do you see how I just wrote all those angles? Yeah. Okay, this is one of the angles. This is one of the angles. I just went around the quadrilateral. I told you that they should add to 360. So boom, equals 360. Okay, 2x plus 2x plus 1x is what? 5x. 30 plus 20 plus 50 is 100 equals 360. Then what?
Minus 100.
Minus 100.
You have to say a honey.
You said honey.
100.
Oh, whoa.
Be literate.
Okay, divide by 5, divide by 5. Anyone know? 52. Good. Shh. And the way you check this one is you can put 52 in for each of those X's and then add them all up and see if you get 360. I'm going to leave this up on the board because I think this was a long one, but we do need to summarize. So today, what did we learn? We learned multi-step is, some of them are 2, some of them are 3, some of them are more than that. So today we learned multi-step equations. I guess you should say we learned to solve multi-step equations. All right. So finish example 6. Write your summary at the bottom of your notes or the top if that's where they fit a little better. I'm going to hand out your homework. I'm also going to pass back your tests. Okay? So we still have a lot to do today.